Hello, good morning everybody. Dear friends, let us see lecture number 10, chapter number 5. We already started miscellaneous exercise. Let us see more examples like this. Here, find f dash x if x is equal to sin x raised to sin x for all 0 less than x less than 1. Suppose y is equal to sin x raised to sin x where 0 less than x less than 1. So what we have to do? Function raised to function is given. So take log y. Log e base sin x raised to sin x, and therefore log y base is equal to sin x log e base sin x base. Now rest of part is very easy for you, so I am giving for you. Okay? So just I am giving hint. Whenever it is so easiest form, then after giving it, I am going to leave for you because it's a miscellaneous form. Now see. For positive constant, we find dy by dx. Where this one? Of course, it's a parametric form. X is equal to some function in terms of dy. This some function of d is given to us. Let us see this one. X is equal to t plus 1 by t raised to n. Some function raised to constant or some function raised to n. In that case, n is constant. So, what happens here? Dx by dt is equal to d by dt of t plus 1 by t raised to n. Some function raised to n or some function raised to constant. N or a times some function raised to a minus 1 d by dt of some function. Why d by dt? Because here we are differentiating with respect to t. So that is equal to, what happens? This can be written as a into t plus 1 by t raised to a over t plus 1 by t d by dt of t plus d by dt of 1 by t. That is nothing but that is equal to ax over t square plus 1. Denominator quantity goes in numerator, that is t. Here 1 by something square d by dt of something. So that is equal to ax t 1 minus 1 by t square over t square plus 1. Can I write here? T square minus 1 into t into ax over t square plus 1 into t square. T get cancelled. What we get? A of t square minus 1 into x over t square plus 1 into t, and put that not equal to 0. This is our dx by dt. What is y? A raised to t plus 1 by t. Now y is equal to a raised to t plus 1 by t. So differentiate with respect to t on both sides. dy by dt is equal to d by dt of a raised to t plus 1 by t. So you know that a raised to some function. A raised to some function log a base e d by dt of some function. Okay. What is this one? By log a base e d by dt of t plus d by dt of 1 by t. That is equal to y log a base e. This is nothing but 1 minus 1 by t square d by dt of t, because 1 by something or some function, that is minus 1 by some function square into d by dx of that some function. So y into log a base e. What happens here? T square minus 1 over t square. That is our dy by dt. And therefore what is dy by dx? Dy by dt upon dx by dt. What is dy by dt? Y into log a base e, or we can write in this way: t square minus 1 upon t square into y into log a base e. So write in that manner. What we get? T square minus 1 over t square y log a base e. Now what is dx by dt? A of t square minus 1 into x. A of t square minus 1 into x over t square plus 1 into t. T square plus 1 into t. T square minus 1, t square minus 1 cancel. 1 by t cancel. So what we get here? 1 by t into y log a base e over ax over t square plus 1. So that was in numerator. What we get? T square plus 1 into t y log a base e over x. This is our answer. Here we can write t plus 1 by t also. If you want to simplify it, we can also simplify it. T plus 1 by t into y log a base e over ax. What is y? That is this one. So what is t plus 1 by t? Log y base a. Log y base a. If you want to replace it, you can replace it. But it is not necessarily you to repeat. Next. See here. Differentiate one function with respect to another function. See. Suppose u is equal to first function. Suppose u is a sine square and v is a e raised to cos x. Derivative of u with respect to v is du by dv. Derivative of fx with respect to another function gx is f dash x over g dash x. Okay? Yeah. So now u is equal to sine square x. What is du by dx? Yes, please tell me. D by dx of sine square x. Some function square 2 times some function d by dx of some function, that is 2 sin x sine some function cos some function d by dx of some function 2 sin x into cos x. Okay? Yeah. Now what is v? V is equal to e raised to cos x. Now v is equal to cos x, so dv by dx is equal to d by dx of e raised to cos x. E raised to some function, e raised to some function, d by dx of some function. What is that sign? Minus sign. Cos some function, sin some function, d by dx of some function into e raised to cos x. So what we get here? So that is equal to minus sin x d raised to cos x. So what is derivative of u with respect to v? And therefore du by dv, derivative of v with respect to v, is nothing but du by dx into dv by d. Dv by dx is this one, minus sin x d raised to cos x. And what is du by dx? Let me see. Yes, du by dx is 2 sin x cos x. So put here 2 sin x cos x, that get cancelled, minus 2 cos x, 1 upon e raised to cos x, that is e raised to minus cos x. You can write in that way also. This is the derivative of first function with respect to other function. Here they can give any function, any two functions. This one is one of the illustration. Okay? Here. Next one. Here. Very simple forms are given. Here. Some function raised to 9. 9 times some function raised to 9 minus 1 d by dx of some function. First of all, suppose by them you can differentiate. So I am leaving for you. Here also d by dx of this plus this. So d by dx of this one plus d by dx of this one. Sin some function raised to n, some function raised to n. Okay. Here see. Y is equal to 5x raised to 3 cos 2x. Function raised to function is given. So what we have to do? We have to take log on both sides. Log 5x is equal to log 5x raised to 3 cos 2x. And therefore y base is equal to 3 cos 2x log 5x base. Now it is very easy. Apply product rule. This and this function is the derivative of this one, derivative plus this one is the derivative of this one. Log something, 1 by something, d by dx of something. Use that form flow, then you get the answer. So I am leaving this one for you. Fourth one, y is equal to sin inverse x root x, 0 less than x less than 1. Can I write here? Sin inverse x raised to 3 by 2x. We can write it. Now d by dx of sin inverse something. 1 upon under root 1 minus something square d by dx of something. That is that. So you are able to do it. So I am doing this one part for you. Okay? Yes. Next one. Here. See. Differentiate this function with respect to x. Call as a y. Cos inverse x by 2 upon under root 2x plus 7. And one can apply directly division rule also. But if possible, then ever division rule. How? Here. Right hand side in terms of x only, so take log. More than 2 functions are given to us, so we take log on both sides. Log cos inverse x by 2, sorry. Log cos inverse x by 2 upon root 2x plus 7. So what we get? Log y base is equal to log cos inverse x by 2 raised to half. So 1 by 2 log 2x plus 7. Now it is very easy to differentiate it. Differentiate with respect to x. Rest of what I am leaving for you, because so many times you already seen this type of sum. So I am leaving this one for you. Yeah, see. Differentiate this function with respect to x. Call as a y. Suppose y is equal to cot inverse under root 1 plus sin x plus under root 1 minus sin x over under root 1 that is equal to x by 2 in a second chapter, inverse trigonometry form. Here I would like to see slightly different. How? First of all, simplify under root 1 plus sin. Can I write here? Sin x is equal to sin x by 2 cos x by 2. Yes. Can we write 1 as a sin square x by 2 plus cos square x by 2? Yeah, we can write it. It's nothing but under root sin x by 2 plus cos x by 2 whole square is nothing but magnitude of sin x by 2 cos x by 2. That is equal to, put the result, 0 less than x less than pi by 2 is given. So 0 less than x by 2 less than pi by 4 is in first quadrant. So sin is positive as well as cos x by 2 both are positive. So their sum is also positive. So that comes out sin x by 2 plus cos x by 2. So result number 1. Now simplify same way 1 minus sin. Also 1 minus sin x. This can be written with minus 2 sin x by 2 cos x by 2. Can I write here sin square x by 2 and here cos square x by 2? Yes, we can write it. It's nothing but under root cos x by 2 minus sin x by 2 whole square, or sin x by 2 minus cos x by 2 whole square, one and same thing. So it's nothing but cos x by 2 minus sin x by 2. That is equal to what? Let us see. First of all, give the result. 0 less than x by 2 less than pi by 4 imply sin 0 0, cos 0 1. Which one is greater? Cos. So cos x by 2 is greater than sin x by 2. So ultimately it comes out cos x by 2 minus sin x by 2. So that is the number 2. And therefore by warning y is equal to cot inverse under root. Here what is 1 plus sin x, here perhaps 1 minus sin x, 1 plus sin x, 1 minus sin x. Let me see. Here. Okay. Replace value. So what we get? Cot inverse. What we get here? Sin x by 2 plus cos x by 2. Here cos x by 2 minus sin x by 2. Over here sin x by 2 plus cos x by 2. Minus sign is there. So minus cos x by 2 plus sin x by 2. And that is equal to cot inverse. What we get? 2 cos x by 2 over 2 sin x by 2. Why? Here sin x by 2 get cancelled. Here cos x by 2 get cancelled. That is equal to cot inverse cot x by 2. That is equal to x by 2. Why? Because where is x by 2? X by 2 belongs to 0 to pi by 4 and is a subset of 0 to pi. Why 0 to pi? Because cot inverse is open interval 0 to pi over cot inverse function. R. Okay? Yes. See. So what we see? Y is equal to x by 2. What is dy by dx? D by dx of x by 2, that is 1 by 2 dx by dx, and that comes out to 1 by 2. Okay? Yes. Next. See. What is given? y is equal to log x raised to log x. No problem. Any function raised to any function is given to us. Log y is equal to log of log x raised to log x base e. And therefore log y base e is equal to log x base e into log of x base e. Now it is very easy to differentiate it. See? Here you have to apply product rule, isn't it? Very easy, so you can do it. Next one is given y is equal to cos of a cos x plus b sin x, where a and b are constant is given to us. Dy by dx is equal to d by dx of all this comes here. Cos something minus sin something, d by dx of something, that is minus sin something here, d by dx of first part plus d by dx of second part. Now it is very easy to see, you can do it. So rest of part I am doing for you, this one is also for you. The next one, see, difference of function raised to difference of function is given, and this condition is given, then this one is positive. So because we are taking log. So next one, y is equal to pi by 4 to 3 pi by 4. What is y? Sin x minus cos x raised to sin x minus cos x pi by 4 less than x less than 3 pi by 4. Okay. Then this one is positive. This is reason why that thing is there. So taking log on both sides, log y base is equal to log e base sin x minus cos x raised to sin x minus cos x. Agree with me? Yes. Now what is next step? Therefore, log y base is equal to sin x minus cos x into log e base sin x minus cos x. Yeah. Now we have to differentiate with respect to x. So what we get? d by dx of log y base e is equal to d by dx of sin x minus cos x into log e base sin x minus cos x. So what we get here? 1 by something d by dx of something. Here product sin x minus cos x as it is, first function as it is, derivative of second one plus second one as it is into derivative of first one into derivative of first one. Okay. So what we get here? And therefore dy by dx is equal to y sin x minus cos x, log something 1 upon something, sin x minus cos x, d by dx of sin x minus cos x plus log e base sin x minus cos x into d by dx of sin x minus cos x. Now see, y as it is. Now d by dx of sin x minus cos x is common and give to separate. D by dx of sin x minus d by dx of cos x. Take it common and give it into other bracket. This comes out to 1 plus this one. Log e base sin x minus cos x. Agree with me? Yes. See, next. Replace value of y. Sin x minus cos x raised to sin x minus cos x. Sin some function, cos some function, d by dx of some function, cos some function, minus sign is there, so plus sin some function, d by dx of some function, rest of bracket as it is. What is that? 1 plus log e base sin x minus cos x. Okay, so what happens this thing? That is equal to sin x minus cos x raised to sin x minus cos x. This comes out cos x plus sin x into second bracket. 1 plus log e base. Yes, what? Sin x minus cos x. This is the answer. Very simple thing is that. Functional part of that. Now you are able to do check everything. Okay? Here. Next one. See. Differentiate this one with respect to x. Okay. Suppose y is equal. Y is equal to x raised to x, x raised to a raised to x plus a raised to a. Where a is positive integer given to us. Okay? Now, what is dy by dx? D by dx of every term, x raised to x, x raised to a raised to x plus a raised to a. And that is equal to d by dx of x raised to x, d by dx of x raised to a, d by dx of a raised to x, d by dx of a raised to a. Giving differentiation to everybody. Every steps. So d by dx of x raised to x is what is some function raised to constant or some function raised to n. A time x raised to a minus 1 d by dx of x. A raised to some function. A raised to some function d by dx of some function. A raised to is constant, so you will see. So what we get here? Put as it is, d by dx of a raised to a x raised to a minus 1 plus a raised to x number 1. Now solve separately this one because here function raised to function is given. So take u is equal to, well, you can take any one. Suppose u is equal to x raised to x. And we know that how to differentiate it. Log u base d is equal to log x raised to the base d. So what we get here? And therefore log u base d is equal to x log x base d. So it is d by dx of log u base d. So many times we done. Even though I would like to solve it once again. So what is d by dx of log something? 1 by something d by dx. X is it is derivative of second one. Second one is it is derivative of first one. So what we get du by dx? Du by dx is equal to u x by x into d by dx of x by log some function 1 by some function d by dx of some function into log x base d. Now replace value of u on both sides. So d by dx of x raised to x is equal to x raised to x. What we get here? 1 plus log x base d. And therefore by 1. What is it? 1? Yeah. Therefore by 1. And therefore by 1. What is dy by dx? This one. So x raised to x into 1 plus log x base d plus what we see? Let me see. Ax raised to a minus 1 plus a raised to x. Ax raised to a minus 1 plus a raised to x into log a base e. Some mistake is that, see? What is a raised to? x. A raised to some function log a by d by dx of some function d by dx of some function plus 0. So what we get here, log a is here 7/1. So we get this thing. This is the answer. Okay? In this way, we can differentiate it. What are the functions are given? U, V, W, you can suppose in that also. But this derivative, remaining derivative are exists, so we are taking this one as a U. Okay? Yes. Next. Okay. Differentiate this function. What we have to suppose? First of all, suppose y. Y is equal to x raised to x square minus 3, x minus 3 raised to x square. This implies y is equal to u plus v, where u is equal to x raised to x square minus 3, and v is equal to x minus 3 whole raised to x square, raised to x square, and therefore what is dy by dx is d by dx of u plus v. Suppose that u and v, so that is equal to du by dx plus d by dx is number 1. Now what is u? Now u is equal to x raised to x square minus 3. If I take log on both sides, then log u. Why we are taking log? Anybody? Because function raised to function is given. So log x raised to x square minus 3 basic is equal to x square minus 3 log x basic. So now you can differentiate it also. Log u basic is equal to x square minus 3 log x basic. Now differentiate, apply product. Same way b. What is b? Also b is equal to x minus 3 whole raised to x square. So what is log b? Log x minus 3 whole raised to x square basic. And therefore log b is equal to x square log x minus 3 basic. Now apply product rule. Say result number 2, 3 by 1, 2 and 3. Say result number 2 by 1, 2 and 3. Replace value of du by dx and du by dx. Then you get the answer. Is of 4 marks. Next, here. This type of sum we already seen. X is equal to a theta minus sin theta, and y is equal to b into 1 minus cos theta. Already seen this type of sum. So here you are going to find dx by dt. What all may be said that is not equal to 0. From here you can find dy by dt. Then what is dy by dx? Dy by dt upon dx by dt. Parametric form is that, so it is very easy to you. You can solve it. So I am doing for you. Next. See. Find dy by dx. This one is that. Dear friends, here y is equal to sin inverse x plus sin inverse under root 1 minus x square. 0 less than x less than 1. Before I take next step, I would like to give the answer. See, we know that cos inverse x is equal to sin inverse under root 1 minus x square is equal to tan inverse under root 1 minus x square upon x. 0 less than x less than 1. You already see in chapter number 2 inverse trigonometry form. So, therefore, what we get y is equal to sin inverse x plus cos inverse x. And therefore, y is equal to pi by 2. Why? Because sin inverse x plus cos inverse x is equal to pi by 2. Whenever mod x less than or equal to, but here it is, see that, it is right, so we can write it. And therefore, dy by dx is equal to d by dx of pi by 2. And that comes out. See, very simple thing. If you are not going to recall the standard form, you can differentiate directly also. Then you also get the answer. It is not necessary that you have to apply this form here. This function y is given to us. Differentiate directly, that is also possible. In that way also you get the same answer. Yes. Next. Yes, very important thing for us. See, here relation is given in terms of x and y. See, this relation is given in terms of x and y. And what we want? We want dy by dx in terms of x. So in examination they can ask also, then express. In place of prove that they can write, then express dy by dx as a function of x only. They can ask in that. Whenever we want dy by dx only in terms of y. If we see exercise number 5.2, 5.3 likewise, in every sum they are giving y as a head. Y is equal to some function is given to us. And some function that is in terms of x. So definitely answer comes out in terms of x. That means whenever we want dy by dx in terms of x only, then simplify given relation so that you can make y as a head of the part. See how to make y as a head. Let me see here. What is given? X under root 1 plus y, y under root 1 plus x is equal to 0. Okay. See here. Can I write therefore x under root 1 plus y is a minus y under root 1 plus x? Yes, we can write it. Because right hand side is 0. To evaluate square root, x square on both sides. And therefore we get x square plus x square y is equal to y square plus y square x. Take it on left hand side it becomes. And write in a manner x square minus y square plus x square y minus y square x is equal to 0. Can I write it? Y square x with x square while y square with x square. So factorize it. X minus y, x plus y, xy common, x minus y equal to 0. Divide by x minus y. What you get? X plus y plus xy equal to 0. From second and third term, take y common and take first term on left hand side. So what is y? Is nothing but minus x over 1 plus x. Very easy. Now y is converted in terms of x only. So now we can differentiate it. And therefore what we get? dy by dx is equal to d by dx of minus x over 1 plus x. We can take it minus and common also. 1 plus x. Apply division rule, minus sign. Denominator quantity whole square, denominator quantity as it is, derivative of numerator minus numerator as it is, derivative of denominator quantity. So what we get, that is equal to this is 1 plus x minus x, derivative of 1 is 0, and derivative of x is 1. Over 1 plus x whole square. X get cancelled. Minus 1 over 1 plus x whole square. And that thing we want. See. What we want? That is in terms of y. See, this type of graph, I would like to take one more extra sample. If x is equal to e raised to tan inverse y minus x square over x cube, then express dy by dx as a function of a quantity. The purpose is a board sum asked in the previous years. So many times this was done, perhaps more than 2 or 3 times. They are changing here some relations. But they want dy by dx in terms of x. So, how to simplify it? See, here x is equal to e raised to tan inverse y minus x square over x cube. Take log. Log is very important tool in mathematics to simplify given function. Yes. So what we get? Log x by z is equal to tan inverse y minus x square over x cube into log e by z, that is 1. So what we get? And therefore log x by z is equal to tan inverse y minus x square over x cube. You can write directly this step also from the very first step. And therefore take tan on both sides. Tan of log x by z, tan of tan inverse, that is y minus x square over x cube. Take x cube on left hand side. X cube tan of log x by z is equal to y minus x square. So what is y? And therefore y is nothing but x cube tan of log x by z plus x square. Plus x square. Or x square plus this thing. Therefore, what is dy by dx? d by dx of right x square first plus x cube tan of log x by z. Now give to every terms. What we get? d by dx of x square, d by dx of x cube tan log x by z. That is equal to something square, 2 times something, d by dx of something, product root, x cube as it is, d by dx of tan of log x by z, plus second function as it is, tan of log x by z, d by dx of x cube. So what we get here? So that is equal to 2x, x cube is tan of some function, sec square some function, d by dx of some function. Write last derivative first. 3 times something raised to 3 minus 1 d by dx of something. Tan of log x by z as it is. So that is equal to 2x log something, x cube by x into d by dx of something, sec square log x by z as it is. Here 3x 3x square of n log x base e. So ultimately what we get? 2x plus x square log x base e plus 3x square n of log x base e. As yes, this is the in terms of x only. So what we want to see? Here we want to see that if x is given in this way, then express dy by dx is a function of x only. And here this one is a given very simple sum. They want dy by dx in terms of x only. If they want dy by dx in terms of x only, then according to this two sum, make y as a head and differentiate with respect to x. It's very easy. Next one, see that. One relation is given here. What is it? If x minus a whole square plus y minus b whole square is equal to c square for some c greater than 0, then prove that this thing is constant independent of area. Of course, in the equation of circle, having center A and B and radius C. This is why putting condition on C is greater than 0. See here. Here what is given? X minus a whole square plus y minus b whole square is equal to c square is given. Find out dy by dx and d2y by dx. So, taking differentiation on both sides with respect to x, dy by dx of c square. So what we get here? Give differentiation to both terms. And here 0. Why? Because constant term is there. Yes. So, what we get here? 2 times some function d by dx of some function. 2 times some function d by dx of some function is equal to 0. To cancel on both sides, x minus what we have to write here? Dx by dx minus d by dx of a. Y minus b. D by dx of y minus d by dx of b is equal to 0. So what we get? X minus a plus y minus b into d by dx is equal to 0. This one is 0, this one is 1, this one is dy by dx, this one is 0. So what is dy by dx? And therefore, what is dy by dx? Minus of x minus a over y minus b. So result number 1. Sometimes we are going to use it. And therefore, what is second derivative? D by dx of dy by dx is equal to d by dx of minus of x minus a over y minus b. So what we get here? And therefore d2 y by dx square is equal to minus sign outside d by dx of x minus a over y minus b. So minus sign as it is, denominator quantity whole square, denominator quantity as it is, derivative of numerator minus numerator as it is, derivative of denominator quantity. So what we get? Minus y minus, you already see this one is 1 minus x minus this one is dy by dx over y minus b whole square minus sign y minus b as it is minus of x minus by 1 replace value of dy by dx x minus say y minus b. Y minus b whole square. And this is due to 1. So y minus b is minus of y minus b whole square minus plus x minus a whole square over y minus b cube. What is this one? Is c square over y minus b whole cube. So that is number 2. Now what we want to see? Prove that this one is constant. So this thing is completed. Let us complete 1 plus dy by dx whole square raised to 3 by 2 separately. Calculate it. Now 1 plus dy by dx whole square raised to 3 by 2. 1 plus minus of x minus a y minus b whole square raised to 3 by 2. So here whole square is that, so y minus b square x minus a whole square over y minus b whole square raised to 3 by 2. What is this one? This one is c square over y minus b whole square raised to 3 by 2. What we get here? C cube. What we get here? Y minus b cube. Here? Yes. So now what we want to see, and then go on. 1 plus dy by dx whole square raised to 3 by 2 over d2y by dx square. Over d square y by dx square is equal to, this one is c square over y minus b cube. Perhaps this one is c cube over y minus b whole cube by 2. See that? Yeah. Minus c square over y minus b cube. That get cancelled. Sorry. This is y cube is there. d2y by dx square. And this one is c cube. And here c square. See, 1 minute. C square over y minus b cube. And here it is c cube over this one. So ultimately comes out c minus, and is constant, not depending on a and b. And that thing we want to prove. See? Prove that this one is constant, independent of a and b. Okay? Yes. So next one. See. Cos y is equal to x cos a plus y with cos a not equal to plus or minus 1. Prove that this thing. I would like to leave this one for you, but let us solve this sum in terms of sine. Sine y is equal to x sine a plus y. Then what happens dy by dx? Then dy by dx comes out sine square a plus y over sine a. So what is here x? X is nothing but sine y over sine a plus y. Now x is a function of y only, so differentiate with respect to y. So what we get here? Dx by dy is equal to d by dy of sine y over sine a plus y. So here we need to apply division rule. Denominator quantity whole square, denominator quantity as it is, derivative of numerator minus numerator as it is, derivative of denominator quantity. Yes or no? Yes. So that is equal to denominator quantity whole square. Sine of a plus y, sine some function, cos function, d by dy of some function. Sine y, sine some function, cos some function. D by dy of a is 0 into d by dy of y. Clear? So what we get here? That is equal to sine a plus y into cos y minus sine y cos a plus y over sine square a plus y. Now think about numerator. It is some standard form. Sine alpha cos beta minus cos alpha sine beta. Here is nothing but sine of a plus y minus y over sine square a plus y. That comes out sine a over sine square a plus y. What is this thing? Is it dx by dy? So what is dy by dx? Is 1 upon dx by dy. And that comes out sine square a plus y over sine a. So same line, you can see this thing also. Yeah. Thank you, dear friends. Next time, only one lecture remaining there. 5 or 6 questions from miscellaneous exercise there. In next lecture, we are going to see that part. And then, I would like to take 2 lectures for multiple choice question based on differentiation also. Thank you, dear friends. And I already submitted assignment for a more practice of differentiation. You can make a practice from that thing also. Thank you, dear friends.